Welcome to this video on variables. My name's Andy Wicks, and in this video I'd like to show you around variables in general. Later videos will go into a lot more detail, but I'm going to start by explaining the term variable. A variable is a place where you can store information in your program. For example, you could have name that stores a name, or age that stores an age. But you can then vary what's in those. So at the moment, the variable name contains Andy Wicks, but I could change that to your name. At the moment, the variable age contains 97, my age, but we could change that to yours. The variable contents can vary, hence the name. But before we get into detail, what I'm going to do is to show you how variables work in general, and for that I need a diagram. When you create a program that uses variables, the interpreter, in this case Python, sets up a table with at least 3 columns. Now what I'm going to do here oversimplifies things a bit, and there are some little wrinkles that when you get deeper into computer science you'd think, why didn't he mention that? The reason is that I want to keep things as understandable as possible at the moment. So it has 3 columns: the variable name, the variable type, and the memory location, and I'm going to explain about each. We start with a variable name. In the last program I had a variable called my_name, which represented my name. That has 2 words. It's important in Python that variable names should be lowercase, and if they contain more than 1 word, separate them with underscores. Now, each variable has a particular type. In some languages you have to set the type, but in Python you don't need to do that. It can work out what type of variable it is from the sort of things that you're telling it to hold. In this case, my name is a string. It's a string of characters, abbreviated to string. A string of characters can be anything on the keyboard, but strings are the subject of the next video. I keep promising you this, but we will get to these things. But that variable, my name, is held in the computer memory somewhere at a particular location. It needs to know where that location is, so it will keep that location fixed. A string can be up to 64K long, so it puts aside up to 64K, 64,000 bytes of information to hold that piece of data. There are ways of improving on that, by the way. Now, the figures I'm giving for the sizes here are not fixed. They depend on the programming language and what it is you're trying to do, but it gives you a flavor for what's going on. So let's get into the different types of variables. A Boolean, something that's either true or false, only takes up 1 byte. An integer, a whole number, takes up, say, 4 bytes. A floating point number, so something with a decimal place in it, takes, say, 16 bytes. And a string up to, say, 64K bytes. Each has a different size, and by knowing the type, it knows how many bytes to read. So if the type of a variable is a string, it knows to read up to 64K of pieces of information in that particular memory location. If it's reading a Boolean, it only needs to know where that memory location is and read that single byte. And that's how all of this works. Now let's go back to the program to see how it works in Python. Here we have a piece of code. The piece of code starts with strg is equal to this is a string. We call equals to initializing something. So strg, which is short for string is going to contain the text, this is a string. String is initialized to this is a string. The next line prints out the string is, and then we're just being asked to press a key to continue. All that does is make the program wait a bit so that you can see exactly what is going on each time. The next piece of code looks at an integer, a floating point, and then a Boolean. Then we're going to get into what happens when we start mixing and matching. So setting an integer works in exactly the same way as setting a string. We initialize the integer to a particular whole number. A floating point number gets initialized to something with a decimal place in it. Now, supposing that floating point number just happened to be 2. What we would do is we'd set float to 2.0. It needs to know that it's a floating point number. Booleans can be either true or false. So Boolean here is being set to true. And we can watch that working in the program. Let me show you those first 4 items running. As you can see, the first piece of code it finds is outputting the string is, this is a string. The second piece of code just shows the integer 97. The third piece of code shows the floating point number 1.61803399. And finally, the Boolean is being set to true. So what we've got here are 4 basic types of information that Python understands. There are others, and we'll come on to those later. But let's go back to the program. Can we mix and match data types? Well, here we've got integer plus float. So what does it do? Does it produce an integer? Or does it produce something that's floating point? And what about the next line? We're setting a Boolean to be integer plus float. How can that be either true or false? Well, let's have a look. The first one, number 5, what it produces is the sum of integer and float. So this is 98.61 and so on. But what about the Boolean? Surely we'd expect either true or false. And what it produces is 98.61. In both cases, it's worked out that it needs to change the type of what it's looking at to match what's coming in. What's coming in is at worst a floating point number. So it can disregard the fact that it started off life as a string. It can disregard the fact that it started off life as a Boolean. In fact, what it does then is find whatever the most useful type is for that particular operation. Now this is good, but it also has problems, because if we do something like that, then we've got to worry about whether what we're doing is going to give us unexpected output. So if we expected Boolean to be either true or false, and later on in the program we try and say, if this is true, do, and we find it isn't true at all, and it isn't false, it's 98.61803399, and that could be a problem. There are other types of data that can be held, things like tuples, lists, and ranges, but we'll be explaining those in later videos. What's also interesting is that you can define your own data types and say how they work. and that is called object-oriented programming. Now that you know what a variable is, we can go and look at the detail of how to use them.